Hey, and welcome. In this video for MakerPlot-J, what we'll be looking at is industrial HMIs, human machine interfaces. Now, really, all of these can act as HMIs that we're interacting with a controller or something as our machine and bringing in data, possibly controlling things. So they're all HMIs. But we're going to look at a more traditional HMI where we're looking at a factory or machinery setting and being able to monitor and control those aspects of it. So we'll click on the HMI example. And we've got some windows that open. Give me a second here. I'm working at lower format than I normally am. Okay. So the first thing, if you're going to test out this example, is to get the Arduino code for it. So we'll go to Open Microcode folder, Arduino code. There's HMI simulation. We'll open up that sketch. I forgot it open, so I won't open it again. But once you download it, we'll be all set to interact with our example now. Make that a little smaller. There we go. Okay, we'll check our serial control. On COM 3, 9600, good to go. And we'll turn the switch to connect to the Arduino. Okay, we see data being plotted. And so per the legend up here, we've got the set point, and we've got the actual temperature, then we've got flow and level down here, and then we've got 3 digital values for motor, heater, and the valve. Now I've forgotten, these are backwards right now. Let's go ahead and fix that while we're here. And I'll fix it again later to when we publish a new version. Let's go into settings, go digital channel, and we'll swap out motor and heater. So those read correctly. So we've got some analog data and some digital data that we're monitoring. So let's go ahead and test the system out. First thing, I'm going to turn the heat way up here for the set point. Okay, we can see that change up there. It's my pointer. Okay. Okay, so let's go ahead and we'll turn the heat on and see it rise fairly quickly. Then we'll go over and turn on pressure. So we turn the heater on, get that going, open up the valve, we see the heat rising, and we get some flow going. And the temperature rise dramatically slows as we pump cold fluid into that heater and it circulates around. Let's back up here and see what happened here once. So I'll turn off the motor. We can see the pressure goes down. Okay, as the motor goes off and our flow went down as well. As turn it on, we'll monitor the pressure and the flow through that. So turning it on, we see the pressure come up, we see the turbine wheel spinning, and we see our flow rates up there bouncing around a little bit. If we close the valve, high pressure area there, and we stop spinning and our flow went down. And then we're heating that fluid up to whatever temperature. Then up here is also our reservoir level. If I turn off the motor, that changes a little bit. Or turn the motor back on again. Okay. So that's essentially what our system does. Then it goes off and feeds something else over here that I don't know what. Was imaginative, think of a whole system we could do. That would make sense. So this is just the feed and heating system, basically, of some plant of operation. So let's look at our Arduino code and see how this correlates to that. So we're plotting our values here, where we got 3 things to read: motor control, the valve, and the heat switch. And plus, along with the temperature set point, just that temperature set point, this is the amount of heat drive we're putting into that heater to keep that temperature at its set point. Okay, so, and then we've got PSI and flow and some levels and some heat drive, good things like that. So let's take a look at this code once and see what we're doing. So let me close that down. We have some variables here: temp set, temperature set point, the temperature, the flow, the pressure, the heat drive, and level. For integer or Boolean values, I should make these Booleans, but we have motor, valve, and heater. So we can keep track of the status of those. couple strings. We set things up. Void loop, we're going to read MPJ, plot from data, control system. So under read MakerPlot-J, we do a serial print and we tell MakerPlot to read and send back to the controller the value of toggle motor, toggle valve, switch heat, and slide temp. Okay, we're going to read that till we get to the end of the line, a new line. And then serial print, we read it all over again. So we get it twice and then do a redundancy check to make sure there wasn't errors in that reading that data. Once it comes in, we're going to take that string that came back with the motor state, that's the valve state, the heater state, the slide temperature value, read those back in and separate them by commas, because they're comma separate up here, and store them into an array, array S for string. And once we have that, we can convert them to integers or to floats and store them in their respective variables. Okay. So in control system, again, we're not really controlling a system here. We're just using the Arduino as a simulation to see what happens with the system as we control aspects of that HMI. So this just goes through if the heater's on and the flow's low, then do this. If the flow's high, then do that with temperature. Else, if the heater's not on, flow's low, do that to temperature. Else, do that with temperature. If the flow's high, so just different responses of the system depending on if you flow or not. If the heater's on, we're going to do heat drive, what value heat drive is going to be based upon the current temperature and the set point, and some random number just to make it bounce around a little bit. Or else heat drive is going to be 0 if the heater's not on. And motors and valves, going to decide what the pressure does based upon the state of the motor and the valve. And again, some randomness to make it bounce a little bit like a wood and reel system. Or for the flow rate down here, figure out what the flow rate would be, or the level in the reservoir. Okay, so we figure all those values. And then for plotting, we send those out as temperature, comma, flow, comma, temp set, comma, pressure, comma, heat drive, comma, level, finally with a new line there. And so when MakerPlot gets that, it takes those analog values and plots those out in that order. Serial print, then we send out some digital values. That % means digital value like 101 for the state of the motor, the valve, and the heater. And what we're going to do then when we update like our pressure gauge, the pressure meter, we're going to really gauge, but we're going to get these values. This can be analog in 0, analog in 1, 2, 3, 4, 5. So those are 8 in values, or our digital values here for doing some of the digital values. We could also update a little bit cleaner, is update it by telling MakerPlot to set meter flow equal to flow, for example. And I think that's supposed to be just flow. I don't think it's called meter flow. I think it's just flow. So there's a little mistake in my code right here. Or meter pressure, be able to just set that value instead of going through the analog plot and taking the in values. It's a little bit more legible, even though incorrect right now, to be able to update those values. So we could just have a bunch of those to update all our different parameters. So that's basically what the Arduino is doing for us. It's acting as a simulator of that system. Okay, so let's take a look at this and see how some of these things were created with it. Okay, now there's two ways we can go about this. We could just do a static background of all our static elements, our pipes and our tanks and everything else, and just add the active controls like the motors and valves and turbines and gauges and whatever else later on. But we could just in Paint or Paint 3D or some higher level application, draw our system out as just an image, and then we go into the settings for the main plot and go into the back image for it So we go to the back image and just select that image we create. Just for a test, we'll use meter faces and select a meter face here, such as this one here. And we'll use that one with the black sides to it and open that. And just assign that stack image as our background and put our active elements on top of it. And that might be easier for some. But in this case, we didn't do that, so we're going to delete all that. In this case, what we're using is individual controls for things. So I'll stop that running for now. Oops, turn it back on. Turn off the system first. Otherwise, that wheel will keep spinning because it loses connection to the controller, to the control system. Okay. So we're going to edit mode F9, and this is just an image. Okay, or this is just an image that we can take and place and assign those. So all we're using for those, if we go to the palette, F2, we're going to indicators and the blank canvas. Okay. And blank canvas controls are used for a lot of things on here to create various things, and we'll demonstrate some use for it. Now we could actually draw lines and ovals and arcs and whatnot on the canvas. So they have a lot of uses to them. We'll just call it canvas test. And we'll draw one on here. And then we'll go assign an image to it. So our image is up here. And if you ever get lost, just type in stuff down here, back image, there we go. Okay, so let's go find a good image. Under HMI symbols. We want a pipe here. We're going to do a pipe, new pipe, pipe small. Pick one of these bronzish looking ones. Open that up. And we've got that pipe on there. Now we can resize it, place it wherever we want in the system. Okay, we can see that's behind everything now. We do plan on adding some pop-up menus to these. We can right-click and do things like bring to top or send it back, and some other things that would be handy to have. But for the time being, we just go into its settings again, find the Z order, and change the Z order from top to bottom. It's lowest to highest. So on the top, we want 0 there. So it'll bring that to the top, and we can place it over the top of other pipes or do whatever we want with it. So it's on top of the other things. Okay. So that's how we can make our pipes and good things like that. Go ahead and delete that one. All right. Next up, let's look at these indicators here. Now this is just a progress bar that I picked a nice color for. And so for that progress bar, what we're updating it from is AN5 as analog N5, which correspond to our level in our tank. So it's just updating using that value to update that progress bar to give us that level. Same down here with this one down here. It's just AN4 for the heater drive to that heater there, heating tank, and be able to update that. So those are just progress bars, nothing real fancy with it. When we look at, let's go ahead and look at, let's look at something next higher level complexity is our active elements for control here, our motor and our valve. Now those are, going into F2 for the palette, those are actually toggle icons that we can click and control. I could just, I think somewhere down here I got some valves and things like that we could have used, in more simplistic icon forms. Do I have a motor in here? I thought I had a motor. Guess it didn't make it to the screen. It's probably in the file, in the image file somewhere. But we'll just call that toggle motor 2. We don't want any text for it, and we'll just draw it on here for a motor. Okay, so we've got an image there for it. So we need to go and change that image. So we look at images as the icon image. So let's go ahead and find a different image for it. We'll go into motors, small, a nice gray one here. That's its normal image. Okay. When it's turned on, since it's a toggle button, we can turn it on or off. We'll make it green. And then we hover over it. We'll set that hover to maybe yellow. Okay. And so we'll test it out. We'll F9, leave exit mode, hover over it, turn it on, it's green, off, and it's back to its normal steel color. Again, when it's off, basically it's a value of 0. When it's on, it's a value of 1. So if the Arduino read that, such as reading the toggle motor down here, it just returns back to it 0 or 1 based upon its state. So you just get that state of that motor. And that's basically, how we can just make our active elements, just using images to do that with. Let's look at these. Now, these are built in. Again, if we go into the indicators, we've got the 7 segments in there. And just a little thing here, when we look at this is we'll F3 this, look at its properties. And so it's using A in value 0 for the current temperature, for its update value. And one special thing about this is the decimal place. Since A in 0 is 3 digits, we have to assign different digit to each 7 segment. So that's using decimal place 1. This one's using decimal place, oops, I'm not edit mode. I click on that. This one's using decimal place 2, and of course this one's using decimal place 3. So we just take that value. We want to go negative with value or to the fractional values. We use -1, -2, so forth for some fractional values as well. So that's how we set those up. It's just a nice looking display. We could have just had a label there saying temperature, but just fancying things up a little bit. Gauges. Our gauges are meters here. F3, again, it's just one of the indicators that we slap down there. Set the min and max. We can right click on these and set the min and max for the alarm min and max values for those. And so it's just updating from A and 3, from that 4th analog value that's coming in from A and 0, A and 1, A and 2, A and 3. And same with our pressure over here. That's just going to be another one. It's going to be A and 1. Analog in 1 that's coming in for our data. So the fanciest thing on here, we have the slider that we can, let me make this a little bigger. I got a few things to fix in this interface. Make it a little bigger so we can actually see those values. So when we are active with this, we can take and adjust that to whatever temperature we want. And again, there's no code for it or anything. Or even update value. We're just having, now the Arduino could update it. The Arduino could send a code of F3, a slide temp is equal to some value, and it'll update that from the Arduino for some set point. If we want to initialize and start things up at a certain level, or we get certain parameters set up, we could do that. Okay. But basically, Arduino is just reading slide temp, and MakerPlot-J setting that data back to be read by the Arduino in that big string. It's nothing too fancy there. Fanciest one is going to be the spinner control down here, this turbine. I'll do one from scratch and kind of show how we did that. So let's go ahead. We'll go to F2 and we'll grab a blank canvas again. Canvas, fan, something decent. Flop it on here. And again, we'll go out and find an image for it. So let's see, oops. And the image background image for it. We'll go digging through our images here, go into our icons, and find a fan down here somewhere. There's one. We'll do that one. That's good. Nice looking. Okay, so we assign the background to it. Okay. Let's go ahead and make this spin once. We'll do that next. Also, I want to turn the border off on that. The border is turned on, so I want to turn the border off. It'll go away when we leave exit out of out of the edit mode here. But when we look at this, it's got a property down here called, let's see, where is it at? Image rotation. So we can set that to be like 10 or 20 or 30. Okay. And we can set those various properties up. Real quick while I'm thinking about this, when we're looking at this one here, let's go back in this one for a second. What this has is it's got the background image. Now that image has a specialized name to it. It's 7-segment -2, or -3, or -4, depending on the image. And then what we're using is image indexing. So if the value for that control is 1, we'll use 7-segment -1. If it's 2, we'll use 7-segment -2, and so on and so forth. And that's how we can get the indexed images based upon the value of the data that we're using for that control. I just want to point that out as I'm talking about making more changes to things here. But yeah, you can come up with a variety of images that will show various states of some system. And based upon a value, 1 to 10 or 1 to 5, whatever it's going to be, show different states of that operation of that component with different images. And so we can see like flames low or flames high, or flames, even higher, or flames out for our different images based upon a value of 0, 1, 2, 3, 4, whatever, and be able to cycle between those images automatically. So that's great for HMIs for the animation purpose, having those different images that are being assigned to it. So when we look at this, we're starting to clip these ends of this fan here. Okay. And so what we're going to do is go into its properties, F3 it, and we're going to take care of that once. All right. So right now it's filling up 100% X and 100% Y, the image width and height. So we're going to make that a little bit smaller and a little bit smaller. Okay, now it's kind of offset though. So we're going to go up to the image X value and make that 5. And image Y, we'll make that 5. And all the image controls when you're drawing or doing graphics is always 0, 0, 0 to 100 and 0 to 100 for the X and Y positions. No matter what size it is, it's always 0 to 100 and 0 to 100. So we can position things and get that nice and centered. Now let's worry about rotating that. We saw the rotation, image rotate property. Let's go ahead and write some code for this. Okay, first thing I want to do is I'm going to use a timer for it. The image control, the canvas controls have a timer. So we're going to perform a timer event with this. And we're going to say that exclamation for instruction, this image rotation is equal to, open brace, do some math here, is equal to get the value of this dot image rotation plus 5. So we're going to increase it by 5. It's going to read the current value of the image and its rotation, okay, or the canvas control, add 5 to it, do the math, and store it back into this control's image rotation. Okay, so this just refers to the image that the control that we're currently coding for. Update code. Okay, so now all I've got to do is turn on the timer. So the timer interval right now is at 0, which means the timer is going to be off. If I set it to, let's say, 100 and come out of edit mode, okay, it's going to keep running that code and keep updating that. If we go to F4, we can see, if I go to instructions, we can see that code's continually running to update, perform that operation to update that code, update that canvas control to spin that image. Again, we can go a little bit faster with it. Let's do 50, and we spin faster, or 20. Okay. Updating this frequently can be a little bit of a strain in the system, but It keeps it pretty well, but it's got to keep pumping that code and running through that code every time to update those. Some of these images, they didn't have an image in the right direction for me. That pointed down, for example, for a motor. So when I went to create that image, I went into the file directory and just made a copy of that, and then using Windows, right-clicked it to rotate left or rotate right or things like that, or do various things with it. For those controls. So sometimes you need to adapt the controls a little bit for the situation that control is going to be in. But that's basically all that came into making this operational, was using those various controls and stuff. Now we could do something. So let's look at this one once. I never looked at the real one. Let's look at this one once. Its code is a little bit different. Okay, this image that rotate, okay, image rotation is equal to this image rotation plus A(n)(1) divided by 5. A(n)(1) is the flow. And I could just put flow there and read directly from the gauge, so that we're reading that actual flow rate, dividing by 5, and rotating the image every 20 milliseconds. Yep, 5 milliseconds, it rotates that around every 20 milliseconds based upon the flow. And so that's why when we run that one, if I didn't break it, we'll find out here. I'll try turning it on once. Okay, we can see it speed up or slow down based upon that flow. As this flow comes up, it spins faster. As the speed slows down, it spins slower. So there's all kinds of tricks we can play. We can actually use the motor here. It really has no code to, it has some code to it to turn the meter set point high or low. But we could also use it to control the timer interval on that, to set that interval to be 0 for off or 50 for when it's turned on, and be able to adjust that then. And again, MakerPlot comes with a lot of pre-designed interfaces for use. And I know people will only tend to use a few of them, might look at the others, but really stick to a couple that they really want to use, or even just a basic plot, which is just a plot and the serial interface itself. But there's all kinds of good information that you can find out by looking at those controls and seeing, how did they do this and how did they do that? And poke around and look at the code and look at the update values and see what was done to make that work. Just like with here, if we click this to view the plot again, what's the code behind there? Well, let's open the interface plot and show it, or interface plot.show. So show that interface window. Okay, same with control. It's got the same type of code for the serial interface serial show. Okay, so turn it on that. Okay, if I turn it on, serial port open. If I turn it off, serial port closed. Plus, I'm using an update value of the actual serial port. So if the serial port closes for some reason, let's say I accidentally unplug my Arduino here, when that serial port closes, that switch goes back off again, saying, yeah, we've lost that connection because it's using that to update that control's value. And so there's a lot of good things you can see poking around these example interfaces and how we did this and how we did that and how we accomplished that. And even make this interface, it's like, well, wouldn't it be nice if it could do this? So we went off and found a way to add that feature, such as a timer. That's relatively new because I wanted some animation there that didn't rely on a external timer to make that run, which is available. You can get an external timer and set that up on the palette. So the palette's got a timer over here that we could just set that up, but it'd be just one more thing for this interface then. So I thought, and the canvas controls are really powerful. They got a lot of features to them. So the more things we can add to it, make it more powerful, the better off it's going to be. Okay, I appreciate you listening, and good luck with your own interfaces. If you ever design one, send us a shot of what you've designed. I'd be happy to take a look at it, and be happy that people can make things with it, and maybe post it on our website with your permission. Okay. Thank you, and have a good day.